All right, so let's take a look at this next example. It says, how long will it take for $8,900 to grow to $25,600 at an interest rate of 5.4% if interest is compounded continuously? Round to the nearest years, round the number of years to the nearest hundredth, excuse me. All right, so we're using A equals PE to the RT. So my A here is the 25,600. My P here is the 8,900. My R here, well, I have to write that as a decimal. So let's do that. Sorry, keep dropping my pens. So that'd be 0.054. And we're trying to solve for T. So the first thing we're going to do is go ahead and divide both sides by the 8,900 because I've got to get that E by itself. Got to get that exponential by itself. So that'd be 256 over 89. E to the 0.054t. Now we're going to use our definition of log to rewrite this as a log equation. So my exponent is 0.054t. And base C, thank God, that's the natural log. That saves us a saves us a step. Can't speak today. So I want to take the natural log of that 256 over 89. So I'm just going to grab it. So that's 0.054t equals 1.0 blah 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 blah. And I'm going to solve this by dividing by 0.054. So be 19.57 years. Let's turn the page and let's do some more examples. Higher potential pH of a substance divided by pH equals negative log of H positive, where H positive is measured in moles per liter. If the pH of a sample of lake water is 7.6, determine the value HP in moles per liter. Express your answer in scientific notation with 3 significant digits. Okay, so our pH is 7.6. So the first thing we need to do is we need to get this solved by the log by itself. So I need to divide both sides by -1. And then we're going to rewrite that as an exponential equation. So H positive would be 10 to the negative 7.6. It's a very small number, but remember, we want this in scientific notation. So to get in scientific notation, I'm going to do my second mode. Nope. Sorry, just hit my mode key, my bad. Arrow down, arrow right until I'm over at SCI. Hit enter. Second quit. And then hit her again. So that would be 2.512 times 10 to the 8th. Sorry, and 10 to the negative 8th, my bad. This would be moles per liter. That's our answer. And then, of course, make sure, since we have to do the next problem, we want to get back to normal mode. So now in the formula, A of t equals A sub 0 e to the kt. A is the amount of radioactive material remaining from an initial amount A sub 0 at a given time t, and k is the negative constant determined by the nature of the material. A certain radioactive decay is a rate of 0.003% annually. Determine the half-life to the nearest 100 years. Now you're looking at this, you're thinking, well, I don't know what anything is. But let's kind of think about what half-life might mean. Let's pretend for a moment we had A sub 0 equals 100 milligrams. Let's say, and then the half-life is we want to know how much would be left over in after the half-life. Well, half of 100 would be 50. So in general, if I have some amount A sub 0, half of it left is going to be half of A sub 0. So let's just pretend A sub 0 is 100 and A sub t is 50. That's just so we can get started with this problem. E. Now it's a decay, so it means it's getting smaller. So this is actually going to be a negative. And I have to change that into a decimal. So I'm going to have to add 2 more zeros. So, because this, when you write as a decimal, you have to slide over 2 more places. That's going to give you 4 zeros between the decimal point, and it's going to need to be a negative because it's decaying, it's decreasing. So actually, we have enough information to solve this now. We divide both sides by 100. That gives us 0.5 equals e to the negative 0.00003t. We're going to rewrite that as a natural log equation. Okay, so let's go ahead and take the natural log. And let me make sure I'm back in the normal mode. Yeah, back in the normal mode. So I'm going to take the natural log of 0.5. That's a negative 0.6931, blah, 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 blah. And I want to be very careful here. I'm going to divide this by negative 0. We need 4 zeros. 3. Going to hit enter. And so t would be 23,100, well, rounding to the nearest 100 years, so 100 years. So that would be our answer.